Welcome to the Explainer. Today, we're diving into Microsoft Azure to figure out who gets into your cloud and who gets told to hit the road. We're going to meet the virtual bouncers that control all the traffic.
So who is in charge of that guest list? Well, let's pull back the curtain on cloud security and meet the folks calling the shots. They're called Network Security Groups, or NSGs for short.
Here's the plan for today. We're going to start with what these things even are, then we'll meet our security guards in a real scenario. After that, we'll trace the exact path data takes coming in and going out, and we'll wrap it all up with how to build smarter, safer rules yourself. Okay, let's get right to it. First things first, what in the world is a network security group? The easiest way to think about an NSG is like a customizable firewall for your stuff in the cloud. It's really just a list of rules that you create, an access list, basically, that decides what's allowed and what's denied. It's your first line of defense, filtering every single packet of data that tries to get in or out. All right, theory is great, but really get this, we need to see these security guards in action. So let's jump into a real-world setup. So this diagram here is going to be our map for this whole explainer. You can see we've got our virtual machines, and we have our two security groups, NSG1 and NSG2. Think of NSG1 as the bouncer for an entire neighborhood, while NSG2 is more like a personal bodyguard for a specific machine. And here are our key players. The most important thing to get is that we can put these bouncers in two totally different spots. We've got NSG1 posted up at the entrance to the whole neighborhood, that's the subnet, and then we have NSG2 standing right at the front door of a specific apartment. That's the network interface card, or NIC. This two-level security is really the key to everything that follows. Okay, let's start by following a little packet of data that's trying to get into our network. This is what we call inbound traffic. And believe me, it has to run a gauntlet of checks to get through. Now this right here is the golden rule. If you remember one thing about inbound traffic, make it this. Azure always checks from the outside in. It starts with the big picture, the subnet, and then moves to the specific, the NIC. Subnet, then NIC. Got it? Okay, let's put this into practice. Take a look at VM1. This machine has double security, right? It's protected by NSG1 at the neighborhood level, and it also has its own personal bouncer, NSG2, right on its network card. That means any traffic trying to reach it has to get past two different bouncers. And here's exactly how that plays out. The traffic first hits the subnet. Bouncer number 1, NSG1, pulls out its clipboard and checks the rules. If it says no, well, that traffic is dropped right there. But if it says yes, the packet gets to move on to the next checkpoint, the network interface. Then bouncer number 2, NSG2, does its own check. The traffic only gets into the machine if it gets a thumbs up from both of them. Now check out VM2. It's sitting right there in the same neighborhood as VM1, but it doesn't have its own personal bodyguard. This changes the math completely, because now there's only one security checkpoint to worry about. So for any data trying to reach VM2, the only bouncer that matters is NSG1. Because there's no security group on its network card, it just gets whatever rules are applied to its entire neighborhood. If the bouncer at the front gate lets you in, you're in. Simple as that. And finally, let's hop over to VM3 in subnet 2. Now, this neighborhood has no bouncer at its main entrance, so traffic can just waltz right in. But VM3 has its own personal security, NSG2, standing guard at its front door. So in this case, the traffic only gets checked at the very last second before it can get inside. All right, so we've mastered how to get in. Well, what happens when one of our machines wants to send something out to the world? Let's trace that outbound journey. Okay, and here's the twist. This is where things get really interesting. For outbound traffic, Azure flips the script completely. For inbound, it was subnet then NIC, from broad to specific. But for outbound, it's the other way around. NIC first, then subnet. It checks from the most specific level out to the most broad. So let's go back to our friend VM1 and follow a packet that's on its way out. Now, following our new rule, where does the journey start? It starts with its personal bouncer, the one attached to its own network interface. And this is absolutely critical to understand. As soon as the packet tries to leave, it gets checked by NSG2. If NSG2 has a rule that says, nope, you're not going anywhere, that's it, game over. The packet is dropped and the bouncer at the subnet, NSG1, never even knows it existed. To get out, it has to pass the night check first and then the subnet check. And this same logic, this exact same pattern applies everywhere else. For VM2, with no personal bodyguard, the traffic goes right to the neighborhood guard, NSG1. For VM3, it gets checked by its personal guard, NSG2, and then its home 3. The rule is always the same for outbound traffic. NIC first, then subnet. So now that we know the exact order of operations for traffic coming in and going out, how do we use that knowledge to build a network that's not only more secure, but also way less complicated? You don't even have to take my word for it. The folks at Microsoft, they spell it out for us right in their own documentation. They strongly advise against putting bouncers at both the subnet and the network interface level. And why? Because when you start layering rules like that, they can conflict with each other, creating all sorts of weird problems that are an absolute nightmare to track down and fix. So really, it all boils down to this. Simplicity is your friend. You should pick a lane. Put your security rules at the neighborhood level, the subnet, or at the individual apartment door, the NIC. Just don't do both. It makes your security setup way clearer, much easier to manage, and a whole lot less likely to give you a headache later. All right, let's boil this all down. What are the key takeaways? For inbound traffic, the check goes from broad to specific, subnet, then NIC. For outbound, it's flipped, specific to broad, NIC, then subnet. If you've got security at both levels, traffic has to pass both checks. And the number one best practice? Keep it simple. Apply your rules at either the subnet or the NIC, but not both. By really understanding this flow, this order of operations, you're not just an administrator clicking buttons anymore. You're a security architect. You're in a position to strategically design your cloud's defenses, knowing exactly where to place your guards to keep your network safe and running smoothly.